Hello students, welcome to YouTube channel Vidya for Success. In this video, we will be discussing about index numbers satisfying time reversal test and index numbers satisfying factor reversal test. Now let us try to prove whether last first price index number satisfies time reversal test or not. Okay. So in the beginning, let us consider the last first price index number. So the last PS price index number, as we know, P01 is summation P1Q0 whole divided by summation P0Q0. Okay. So in the last PS price index number, we will be considering the base year quantities. Okay, and also in the formula P01 indicates price index number for the current year 1 with respect to the base year 0. So the base year is 0, indicated with 0. But for time reversal test, in order to prove the time reversal test, we need to consider a new index number. The new index number is P10. What is P10? P10 is a new price index number for the current year 0 and base year is 1. So nothing but we can notice here there is a change in the time periods. Okay, so a new index number need to be identified. So P10 is equivalent to summation P0Q1 whole divided by summation P1Q1. Again, here in the new index number, after reversing the time, which is the quantity, again we are going with the base year quantity, because here in this particular time reversed price index number formula, the base year is 1. Okay, so that's why Q1 both in the numerator and denominator we have considered Q1. Next, according to time reversal test, P01 into P10 should give us the answer 1. Okay, so already we are having what is P01, the price index number for the current year 1 with respect to base year 0, already we know. Similarly, we know what is the price index number for the current year 0 with respect to base year 1. So substituting those values, we will try to cancel out the numerators and denominator. We will check it out. So in both the formulas, there is no common values. Since there are no common values, we cannot cancel the values. Since we cannot cancel the values, the ultimate answer will not be equal to 1. So that's, we can say that last first price index number does not satisfy time reversal test. Another important noticeable factor here is actual last first price index number is P01 summation P1Q0 divided by summation P0Q0 multiplied by 100. Yes, I hope you know this. But here we are not considering the percentage factor, okay, because we are considering only the constant proportionality factor. Okay, we are going with only the constant ratios, not with percentage. So that's why in both the formulas, that is P01 and P10, we have not gone with multiplying with 100. Just we have considered the mere ratios. Now let us prove whether Pasch's price index number satisfy time reversal test. So for that we need to consider the Pasch's price index number. So P01, that is price index number for the current year 1 with respect to base year 0, is equal to summation P1Q1 divided by summation P0Q1. So both in the numerator and denominator we have considered current year quantities. So Pasch's price index number considers current year quantities. So in order to prove the time reversal test, we need to go with reversing the time periods. After reversing the time periods, we will be getting a new price index number. The new price index number is P10. What is P10? Price index number for the current year 0 with respect to base year 1 is equal to summation P0Q0 whole divided by summation P1Q0. So now the current year quantities are Q0. Okay, you can notice in both the numerator and denominator we have gone with Q0. In order to prove the time reversal test, according to time reversal test, P01 into P10 should yield you the value 1. Okay, by substituting the values for the respective price index number, we will not be able to cancel out any of the values in each of these price index numbers. So it's nothing but the ultimate answer what we are going to get is not equal to 1. So that's, we can say that Pasch's price index number does not satisfy time reversal test. Now we need to prove whether Marshall-Edwards price index number satisfies time reversal. So the approach what we have followed in the earlier two contexts, the same thing follows here also. So over the screen you can notice according to time reversal test, I have cancelled out some of the numerator and denominator values and we have left with only value 1. So that's why we can straight away say that the Marshall-Edwards price index number satisfy time reversal test. So now we need to prove whether last year's price index number satisfies factor reversal test or not. So we know the price index number for last year's P01 is equivalent to summation P1 Q0 whole divided by summation P0 Q0. For last year's price index number, we will be considering the base year quantities. So for factor reversal test, we need to consider quantitative index numbers. So last year's quantitative index number is Q01 is equal to summation Q1 P0 whole divided by summation Q0 P0. So here we will be considering the base year price. Both numerator and denominator you can notice base year prices P0 P0. Okay. So what is factor reversal test? Price index number into quantity index number should give us the total value. Okay, so that's what we can notice on the screen. According to factor reversal test, P01 into Q01 should give us V01. What is V01? Value, total value, value index number. Okay, so by substituting the values for P0 and Q01, we will not be able to cancel out any of the values. Since we will not be able to cancel out any of the values, we will not be getting the total value, that is value index number. We will not be getting summation P1 Q1 divided by summation Q0 P0. We will not be getting the final needed answer. That's why we can straight away state that last year's price index number does not satisfy factor reversal test. Now we need to prove Fisher's price index number satisfies factor reversal test. So for that we need to consider the Fisher's price index number. So the price index number P01 is equal to square root of the summation P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q1. This is the Fisher's price index number. Similarly, we need to consider Fisher's quantity index number. Q01 is equal to square root of summation Q1 P0 divided by summation Q0 P0 into summation Q1 P1 divided by summation Q0 P1. So this is the Fisher's quantity index number. So we need to, in order to prove factor reversal test, we need to multiply Fisher's price index number and Fisher's quantity index number. After multiplying, we must get the value index number. Okay, so what is the value index number formula? The value index number is summation P1 Q1 divided by summation P0 Q0. This is the formula. We must get, after multiplying the Fisher's price index and quantity index number, ultimately we must get the value index number. After substituting the values for P01 and Q01, we will be trying to cancel out the common factors. After cancelling these common factors, we are left with some of the values which cannot be cancelled out. They can be put like this: square root of summation P1 Q1 divided by summation P0 Q0 whole square. Okay, so now cancelling the square root with the square value, we will be left with summation P1 Q1 divided by summation P0 Q0, which is nothing but value index for the current year 1 with respect to base year 0. Thus we can say that Fisher's price index number satisfies factor reversal test.